Let's find the initial amount in a word problem on continuous compound interest. So we're working with the same formula again. A equals P times e raised to the RT power, that continuous compounding formula. Well, we talked about what all these letters are, so let's just jump into these examples. So Mr. and Mrs. Sun hope to send their son to college in 14 years. So I think we just identify the time. T is 14. How much money should they invest now? So we're looking for the present value of this investment. We're looking for P. Find P. Because of this wording, how much money should they invest now? All right, hold on. Let me try to highlight this in orange. How much money should they invest now? Okay, so we're looking for the present value of this investment. And it says, at an interest rate of 8.5% per year. So I'll go ahead and write down that R is 0.085. And when they said this wording, compounded continuously, I'm going to go ahead and write down A equals PERT. Okay. In order to be able to contribute $50,000 to his education. So we are given A, the ending amount that Mr. and Mrs. Sun want is 50,000. So we don't know what the initial value is, but we have the goal amount of 50,000. So we're going to plug in 50,000 on the other side, but keep P as P. That's what we're trying to find. And we're going to say E is getting raised to the R. R is 0.085 times T of 14 years. Now look, if I just want P by itself, notice P is getting multiplied by that exponential term. So all we need to do about this problem is just divide both sides by that exponential term. Now let me see if I can just copy this on the other side too. That's the goal. I'm just going to divide both sides by... Uh-oh, what's going on? I think my note-taking app just froze. All right, give me 1 second. It didn't want to duplicate it for me, so I have to just write it myself. All right, so that's what we're doing. We're dividing both sides by that exponential term. So what will happen on the left-hand side, the right-hand side, this exponential term will just cancel out. So let me go ahead and say this will cross out on this side. So this is out and this is out. But P is simply going to be just that 50,000 divided by that exponential. So 50,000 divided by e to the 0.085 times 14. Oh, so that's exact. That is the exact form. But, you know, that's not so helpful to this couple. So what we're going to do is we're going to get the approximate decimal value of this. And I'm just going to round this to the nearest cent because this is about money. So let me type this in now. 50,000 divided by e raised to the 0.085 times 14th power. Oopsies. And the amount that this couple need to invest today is $15,211.06. If they have that much money today and can find a financial institution that will let them have, 8.5% per year, compounding continuously, and if it's going to take them 14 years, but that initial amount will grow to be $50,000 for their son by the time he goes to college. But that's how you can find the initial value problems. Once you set it up, we just have to divide both sides by that exponential term. All right, let's look at number 6, another similar problem. How much should be invested now? If you look at the wording of this, how much should be invested now? They're asking for P. Okay, they're asking for the present value. Okay. find P at an interest rate of, what are they giving us? Rate is 0.0675 and it's compounding continuously. So because of that, I will write down A equals hurt. But we need a couple more information. How much do they want in the end? So to have, look, 4,500 in how many years? 4 years. So we know all these numbers that we need to plug in. All right, so let me start plugging these in, okay? So A is the ending amount that we want to walk away is 4,500. We don't know what P is, but that P is getting multiplied by E raised to the 0.0675 times T, the time of 4 years. All right, remember what we did to both sides, right? We're going to divide both sides by that exponential term because P is simply getting multiplied by that exponential term. Okay? So if I do that, P is exactly 4,500 divided by E to the 0.0675 times 4th power, but we should round this to a decimal value because this is amount of money. 4,500 divided by E to the 0.0675 times 4, and that comes out to be $3,435.21. So if we have $3,435.21 at a rate of 6.75 per year, compounding continuously, if we wait 4 years, we're going to end up with $4,500. We're going to gain about $900. But that's how you can do present value problems.